So today we're going to be tackling a question that only 17% of students got right. So part A, pretty simple. It's in the formula book. It's just a geometric series. Part B, I'm going to choose to write the complex number in terms of its polar form. And this makes a lot more sense the further we get in the question. So it's keen observation to notice that 1/2 of sine theta plus 1/4 of sine 2 theta plus dot 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 is the imaginary part of the sum given in part A. So now that we've got that in polar form, we can use our answer from part A, and we get that the sum is then 1 over 1 minus 1/2 e to the I theta. But in the question, we're given the form that we want our answer in, and we have a real denominator. And since we have a real denominator, we want to times by the complex conjugate. So we're going to be multiplying by 1 minus 1/2 e to the minus I theta. And this makes the denominator real. So after we do this, we just expand our brackets. We're going to end up with something like 1 minus 1/2 e to the minus I theta over 1 minus 1/2 e to the I theta times by 1 minus 1/2 e to the minus I theta. And then when we've expanded this, we're going to get a part where we can use our trigonometric identity that 2 cosine theta is e to the minus I theta plus e to the I theta. And that way it allows us to make the denominator real by using the polar form. So I'm just collecting the terms here. And you see we have this e to the I theta plus e to the minus I theta. That is just 2 cosine theta. We know this. It's one of our identities. So after timesing 3 by 4 to get rid of all the fractions, we're going to be left with 4 minus 2 e to the minus I theta over 5 minus 2 lots of 2 cosine theta. So then if we carry on expanding this out, we're going to get 4. And here I'm just using the definition of our complex number. E to the minus I theta is cosine of minus theta, which is just cosine theta. And then sine of minus theta is minus sine theta. So then after expanding it, we find the imaginary part of this is then just the only part that has an I in it is 2 sine theta on the denominator. So we get it's 2 sine theta over 5 minus 4 cosine theta. And then we're moving on to part 3 of the question.